This is the QuickField simulation example. ISO 10077 standard test case 8 roller shutter box. This is the example webpage on QuickField.com. Here you can find all the information that you want. This is the geometry model that we will deal with. This is the box, and here we have a goal side, and here the wrong side. This is the insulation panel, this is the PVC frame, and on this edge we have a zero flux boundary condition, so we do this boundary condition here. Also we have main dimensions given here. Thermal conductivities of the insulation panel and PVC are also given here. Our task is to calculate two-dimensional thermal conductance in accordance with ISO 10077 standard. And for reference, thermal conductance is given here in comments. Here we have some comments regarding the problem solution, and the crucial moment is that when dealing with air gaps we should take into account that in reality heat transfer is the process of convection and radiation heat transfer. So in order to calculate equivalent values of thermal conductivity, which we will use accompanying Excel spreadsheet. This is the QuickField window. Let's take a look at the problem properties. This is the steady state heat transfer problem, and the model class is plain parallel one. Now let's take a look at the problem geometry. Here it is. There are a lot of air blocks here. And we set initial value of thermal conductivity in all of them. This is the insulation panel with the value of thermal conductivity 0.035 and the PVC frame. As for the edges, we have a zero flux boundary condition on this edge, and the convection boundary condition on the goal side, which is the left side, and a piece of bottom side. And on these edges, on the right and on the bottom, we have a convection boundary conditions with the temperature equals to 20. And now let's go to the Microsoft Excel. Here we have a brief instruction how to deal with this document. First, we have to list error blocks in the first column. Here it is. When we type 1 or 2, depending on the block type, in the second column, and in the third column we set initial and general conductivity of the error blocks. After that, we start calculations. First iteration is done. And after a few iterations we will get appropriate values of the general conductivity. Now the relative error is pretty small, and we can get to QuickField. This is the temperature distribution, and in order to calculate equivalent thermal conductance, we should add the relevant edges to the contour of integration. So the value of the heat transfer is about 3.6 watts, and the sign depends on the control destination. Now that I divide this value for the temperature difference and get the value of the equivalent thermal conductance. And one can see that this value matches the reference one pretty good.